Hello, wonderful people. This video is on dividing decimals, everyone's least favorite thing. I hope to convince you it's not that bad, and it might actually be a little bit easier than multiplying decimals. So, there are many different ways to divide decimals, just like multiplying decimals. But in this video, I'm going to show you a few good methods of dividing decimals. So we've got a method called common denominators. That is fractions, you guessed it. We've got equivalent fractions, that's fractions. And then I put this other method here underneath this squiggly line, long division, because that we're going to need to use long division in a lot of these problems, but only kind of as a last resort when we can't see the answer really clearly using one of these other methods. I'll show you all three. Okay. So first method is common denominators. So in this method, you'll turn the decimals into fractions with a common denominator. Sometimes they'll already come with common denominators, like you might be working with two numbers that are already in hundredths, or sometimes one of the numbers will be in tenths, the other one will be in hundredths, and you have to make sure that they have common denominators so that you can super easily divide across. Our purpose here is to create a really easy to solve division problem. So after you have a common denominator, you just divide across and then turn the quotient into a decimal if needed. Sometimes it will be, sometimes it won't be. Okay, so let's check this out with an example. 0.56 divided by 0.08, also known as 56 hundredths, divided by 8 hundredths. So we're going to turn these into decimals, turn these decimals into fractions with a common denominator. So, as I just said, this is 56 hundredths, and this is 8 hundredths, and voila, we can just divide across. 56 divided by 8 is 7. 100 divided by 100 is 1. Boom, we got a really nice, easy to solve division problem here. So 56 hundredths divided by 8 hundredths is 7. Pretty nice, right? Cool. All right, so let's try another method. Let's try equivalent fractions. This is the way my brain works. So if yours doesn't, you think more like common denominators or long division, that's totally fine. I favor this method. It doesn't mean it's the only method, it's just how I think about it. So you want to start by writing the division as a fraction instead, just another form of division, dividend over divisor. Then find an equivalent fraction where both numerator and denominator are whole numbers, and then divide. So let's see that with this same example. So instead of 56 hundredths divided by 8 hundredths written like this, I'm going to turn that into a fraction. So remember, dividend, divisor, numerator, denominator. So I can rewrite this as 56 hundredths over 8 hundredths. But this is kind of a weird fraction. This is what's called a complex fraction. So I've got to make sure I can find equivalent fractions where both the numerator and denominator are whole numbers. So, okay, I can start by multiplying by 10 over 10 and get 5.6 over 0.8. These are still not whole numbers. So I've got to multiply by 10 over 10 again. And I've got 56 over 8. Well, that's just 56 divided by 8. And that is 7. We knew we should have gotten 7, so it's good that it worked out that way. So this is equivalent fractions, just making sure you turn this complex fraction into a regular old fraction. Sometimes it's an improper fraction, but without any decimals, and then just divide. All right, now let's say the problem wasn't so simple. Like we kind of know that 8 hundredths goes into 56 hundredths 7 times. Like that might have been one you knew off the top of your head. But what if it wasn't that simple? What if it was something like 60 and 8/10 divided by 4/10? So this one we might need to use long division or a combination of a couple different strategies. So just by looking at this, remember estimation is really good to do to check to see if your answer is reasonable. So this is the divisor and it's way less than the dividend. So I know my answer is going to be much greater than 1. In fact, this is like asking how many times will number close to half go into this. So I think my answer, I would estimate it's going to be like double, if not more, of 60. So I would expect my answer to be greater than 120. So let's just make sure our answer is around that or higher. Okay. So I'm going to use the equivalent fraction strategy and see if I can solve it that way. So I've got 60.8 over 0.4 that has too many decimals. So I'll multiply by 10 over 10 to get 608 over 4. But I'm kind of looking at this. I know some ways that I could reduce this, maybe like divide numerator and denominator by 2 or divide them both by 4. But once I get to dividing by 4, that's exactly this problem I have here. I'm just going to switch over to long division to get an answer really quickly. So remember, in long division, we've got the dividend here and the divisor here. So numerator, denominator. So we've got 608 divided by 4. This is long division using the standard algorithm. Some of you might do partial quotient. I like the standard algorithm when there's a chance that there might be a decimal answer. So that's what I'm going to show you here. All right, so 4 goes into 6 once. 1 times 4 is 4. 6 minus 4 is 2. Bring down a 0. All right, 4 goes into 20 5 times. 5 times 4 is 20. So it looks like I have a remainder of 0, except I have to keep going because there are more numbers in the dividend to work with. So I'll bring down this 8. 4 goes into 8 2 times, so I put the 2 up there. 2 times 4 is 8. And now I'm really done because I have a remainder of 0 and no more numbers in the dividend. So that means that 608 divided by 4 is 152. Is that at least double 60, the 120 or greater? Yeah. And it's like roughly, it's not exactly my estimate, but it's roughly my estimate. It's not 15.2. It's not 1,520. It's has the same number of digits I expected it to. It's 152. So that's long division. I'll show you a couple more where we might use a combination of strategies. At any point in time, feel free to look at the question, pause it, then pick it back up to check your work. So 78 divided by 90. People hate problems like this because this I just know is automatically going to be less than 1. It's going to be a decimal answer. There's no whole number because 90, it can't go into 78 even one whole time. This you might also recognize as a proper fraction, 78 over 90. I don't know what the decimal equivalent of this is off the top of my head. I already have a whole number numerator and denominator, so I don't need to change it. I don't need to make an equivalent fraction. I'm going to jump straight to long division here because I don't know how many times 90 goes into 78. So let's try it out. So I've got 78 divided by 90. Remember I said that I know 90 doesn't go into 78 even once. So I'm just going to go ahead and say, like, let's call this 78.00. I don't know how many zeros, I'll put 3. And I will add a decimal to my quotient because I know it's going to be less than 1. For example, 90 doesn't go into 7. It doesn't go into 78. I know there is a hidden 0 here. So 0 times 90 is 0. And if I subtract 0 from 78, I get 0. And I could bring this 0 down. So now I'm asking, how many times does 90 go into 780? So let's think about that a little bit. Well, I know 90 would go into 720 8 times. So 8 times 90 is 720. And I've got 60 left over. But since I have a remainder down here, I have to keep going. So now I'll ask, how many times does 90 go into 600? Well, I know 90 goes into 540 6 times. I can't go up one more because 97 times is 630. So 6 times 90 is 540. Subtract and I get 60 left over. Bring down a 0. Are you starting to see something here? Look at this. How many times does 90 go into 600? Well, 6 times with 60 left over. Are you seeing that I'm going to keep getting a remainder of 60 every single time here? I'd bring down another 0, say 90 goes into 600 6 times with 60 left over, and that would keep going on forever and ever and ever. So what we have here is a repeating decimal. I know that this 6 is just going to keep going on forever, so I can actually write this as 0.86 with a repeating bar over the 6 because the 86 doesn't repeat, just the 6 repeats. So that means 78 over 90 as a decimal is 8 or 0.86 repeating 6. All right. Feel free to stop watching at any point in time if you're getting super bored by this, but I just wanted to show you one more example. So let's try 35 divided by 14 thousandths. Would you expect this to be a really big or a really little number? Ask yourself, how many times does 14 thousandths go into 35? If you're like me, you're going to be expecting this to be a really large quotient because this is a teensy tiny little divisor and it will go into the dividend a bunch of times. So I'll start by writing this as a fraction, 35 over 0.014. Okay, it's not a whole number in both numerator and denominator. So I know that I would have to multiply 14 thousandths by 10 by 100 by 1,000 to get it to be a whole number. So I know I'm multiplying by 1,000 over 1,000. And that will mean the 14 will finally be a whole number. But the 35 becomes 35,000. Whoa, that's crazy. All right, so now I have 35,000 divided by 14. I don't know about you, but I don't know how many times 14 goes into 35,000 off the top of my head. So let's jump to long division. So I've got 35,000 divided by 14. Okay. 14 does not go into 3. However, 14 does go into 35 twice. 2 times 14 is 28. And if I subtract, I get a remainder of 7. I have a 0 to bring down still. So I have 70. 14 goes into 70 5 times, actually evenly. 5 times 14 is 70 exactly. So I have a remainder of 0 here. So this is kind of like the last one. It seems like I'm done. But 14 goes into 35,000 way more than 25 times, because I actually still have numbers here in my dividend that I haven't used. So I'll pull a 0 down. How many times does 14 go into 0? Well, 0 times. Yeah. 0 times 14 is 0. I know this seems kind of like a little tedious and silly, but it'll help you get the right answer. Then 0 minus 0 is 0, obviously, but keep going. Bring another 0 down, the last one in the dividend. How many times does 14 go into 0? 0. So we write a 0 up here in the quotient. 0 times 14 is 0. I've got a remainder of 0. Finally, I'm finished. Okay, so that means that 35,000 divided by 14 is 2,500. A lot of people ask, well, don't I have to go back and put in the decimal here? Well, let's think about it. Where would you put a decimal? We predicted that 14 thousandths would go into 35 a lot of times. We need several thousand times for it to just get to a whole number. And then, you know, we're going into 35 here. So this seems like a reasonable answer. But the other thing that you really have to realize here is that 35 divided by 14 thousandths is equivalent to 35,000 divided by 14. It's equivalent because we just multiplied by a form of the number 1 here. So it's like we took this, multiplied it by 1. We got a different fraction, but it's exactly equivalent to this. So our division problem is exactly equivalent. That's why this equivalent fraction strategy works. So even though we had a bunch of decimals here in the divisor, we don't need to do anything to the quotient because we've created an equivalent division problem that was a lot easier to solve. So that is it for dividing decimals. Just as a reminder, I am trying so hard to find the cover page. There it is. Okay, you had a bunch of methods, common denominators, equivalent fractions, long division. I think you saw that sometimes you need a combination of all of these methods to get the right answer. Use what makes most sense in a problem. Good luck, and see you later.